So in this problem, they have given Z phase. In this problem, they have given Z phase. Z phase is equal to R plus J XL. They have given R value 8 ohms. What is XL value?
6, sir.
What is 6 ohms? And they have given line voltage. VL is equal to 400 volts. Okay. In this problem, they have given R and XL value. But in the next problem, we have to determine R and XL value. In the next problem, what we are going to do, we have to determine R value and XL value. See, next problem. Take down this problem. Example 19.3. Take down example 19.3. Take down this problem. Example 19.3. Write the question. Have you written the question? Have you written the question?
Yes, sir.
Okay. See here now. So in the problem, they are giving a star connected inductors. Inductor contains not only pure inductance, but some resistance is also included in this. First, draw the diagram. R and XL. Okay. We have to determine R and XL. He is asking to determine the circuit constants. In the problem, he is asking the circuit constants. Circuit constants means R, L, and C. Circuit constants means R, L, and C. But he is specifying only inductor. Inductor means there is no capacitance. It is RL circuit. It is the RL circuit. So I am taking three phases here. In all the three phases, equal amount of inductors are there. This is the first phase. This is second phase. This is third phase. And they are giving the line voltage. What is the line voltage they are giving? In the problem, always line voltage is given. What is the voltage? In the problem, they have given line voltage. What is that voltage?
460 volts.
460 volts. Okay. Line voltage means in between two phases. In between two phases, line voltage. And they have given the power. What is the power they are giving? What is the power?
0.
Anyone? That is power factor. Power I am asking. 8 kilowatts. They are giving the power of 8 kilowatts. See, 8 kilowatts means 8,000 watts. He is giving the power 8,000 watts, and power factor he is giving cos phi, that is equal to 0.8. Your cos phi is 0.8. He is giving the power factor of 0.8. Now, in star connection, what are the formulas? VL is equal to, in star connection, VL is equal to root 3 into V phase. IL is equal to I phase. Because star connection is the series connection. In series, current will be same, but voltage will be different. That's why VL is equal to root 3 into V phase. Now, V phase means voltage in between phase and neutral. V phase means voltage in between phase and neutral. This is the neutral, this common point. Joining of these three branches, 1, 2, 3, these three branches at a common point. This is called neutral. Voltage in between phase and neutral is the V phase. Okay. Now can you determine the phase voltage? I am removing this diagram. V phase is equal to VL by root 3. VL is 460 by root 3. What is this value?
65.58.
Okay, 265 volt. In your textbook, they are giving approximately 265 volts. Okay, whatever you are getting, you can take that. Now, in the problem, what he is asking us to determine? What he is asking?
Circuit constant, sir.
Circuit constant. Circuit constants means R and XL. Circuit constants means R and XL. We have to determine R and XL in each phase. Okay. Now see here. They have given the power. We know power P is equal to. Sorry. What is the formula for P? What is the formula? 3 V phase I phase cos phi or root 3 VL IL cos phi. We can take any formula. If you are taking V phase I phase, we will take 3 here. If you take VL IL, we will take root 3. Is it okay? Take any formula. What is power P? 8,000 watts. Power P is 8,000. I am taking the first formula. 3 V phase is 2. How much V phase? 265. I phase I don't know. I don't know the I phase. What is cos phi? 0.8. Determine the phase current. Determine the phase current from this.
$12.57, sir.
Okay, 12.55 ampere. 12.55 ampere. Your current is 12.55 ampere. Now your V phase. Okay. In the problem, what he is asking? Find the circuit constants. Okay. Now I know V phase 265 volts. Therefore, your Z phase is equal to V phase by Z phase. If you are taking phase here also V phase, I phase. There is no concept of line impedance. Only phase impedance is there. In each phase there will be phase impedance. Phase by phase. Okay. We know V phase is 265 divided by 12.55. How much?
21.2, sir.
21.2. What is this? Ohms. Now Z phase is equal to R plus JXL. We had to determine R and XL. In the problem, he is asking us to determine R and XL. R is taken on the x-axis. XL is taken on y-axis because J is 90 degrees. J means 9 plus 90. J means plus 90. Resultant of R and XL is Z. Resultant of R and XL is Z. This is your phi. Your Z is 21.2. 2 ohms. 21.2 ohms. And you know cos phi. What is cos phi? 0.8. What is phi from
0.8.
this? Okay. What is phi? Cos inverse of 0.8?
32.
30?
36.86.
36.86 degrees. This is your phi. Now I know phi and z. From this I can determine cos phi. From the triangle, cos phi is equal to R by Z phase. Cos phi is 0.8. R by Z phase is 21.2. From this I will get R phase. And similarly, sin phi is equal to XL by Z. I know phi and Z. From this I will get XL. R is
16.96.
16.9 ohms. And the XL is XL is 12.66 ohms. XL is 12.66 ohms. So this is the procedure. What is the difference between the first problem and this problem? What is the difference between first and this problem? In the first problem, they are giving R and XL. In this problem, they are asking us to determine R and XL. That is the difference. In the first problem, they have given R and XL, but in this problem, we are determining R and XL. See the difference. See, this is the solution they have prepared. They have given in the textbook. Your R is 16.9 ohms and XL is 12.66 ohms. XL is 12.66 ohms. Next, we will do the next problem. Take down this problem. Example 19.5. Take down this problem. Example 19.5. Example 19.5. Is it visible screen?
Yes, sir.
Yes, sir, it's visible.
Take down the problem. 19.5, example 19.5.
Yes.
After writing the problem, you can inform me. Have you written the problem?
1 minute.
Yes, sir.
Yes, sir. Done, sir.
Have you written the problem?
Yes, sir.
Okay. See here, in the problem, he is giving three identical star-connected coils. Three identical star-connected coils. Coils means what is this circuit? RL or RC? Coils means
R6.
it is an RL circuit. Okay. See here, it is an RL circuit. Draw the circuit. This is an RL circuit. Coil means RL circuit. Coil means RL circuit. This is the circuit, and the voltage he is giving is always they'll give line voltage in the problem. Always they'll give line voltage, 440 volts. He is giving power. Power is 6 kilowatts. 6 kilowatts he is giving the power. In the problem, he is giving line current or phase current. He is giving line current or phase current. IR is equal to, IR is the phase current. In one phase, the current is flowing. IR, current in the R phase. Let us take this is R, Y, and B. Three phases are there. R, Y, and B. R, Y, and B. Three phases are there. In the R phase, current flowing is 30 ampere. R phase means in the single, this is the phase current, 30 ampere. He is giving the phase current, I phase. He is giving 30 ampere. And he is asking us to determine R and XL. R and XL, power factor and reactive power. So first I will determine Z phase. For that I am using the power P. P is equal to, what is the formula? Three into V phase I phase cos phi. If you take root 3, VL IL. And what is the V phase here? V phase is equal to VL by root 3. Your VL is 440 by root 3. That is equal to
254.03.
okay, 254 you take. 254 volts. 254 volts. 3 into 254. I phase is 30. Cos phi you don't know. They have not given. In the previous problem they have given cos phi, but in this problem they are not giving cos phi. We have to determine cos phi. Cos phi. So verify it.
So cos phi is 0.026. Sir.
Cos phi is 0.
026.
No, it is wrong. 0.787 you will get. Keep your calculator in the degrees mode. I think your calculator is in radians mode. See? Your calculator is in the radians mode. And the top of your screen, you are getting R, I think. You have to get D. D means degrees.
No, sir. 0.26.
0. Everyone is getting that answer? What about the remaining students? What about remaining students?
Sir, cos phi is 0.262, sir.
262 you are getting?
Yes, sir. 2624.
Yes, sir, 262 only.
And the
Okay.
angle is 74.78, sir.
0.262 you are getting?
Yes, sir.
Okay. If everybody is getting this answer, take this answer.
Yes, sir, that only we have it.
Please 74.78.
Okay. $74.78. Okay. If everybody is getting this answer, this will be right. Okay.
Yes, sir.
Now see here. Now I will determine Z phase. Z phase is equal to V phase by I phase. V phase by I phase. Your V phase is 254. Your I phase is 30.
8.46, sir.
8.47. In your textbook, they are giving 8.47 ohms.
Yes, sir.
Now Z phase is R plus JXL. Draw the diagram. This is R. This is XL. This is your Z. 8.47. 8.47 Z value. And you know phi value. Phi is 70. How much?
74.78.
74.78. This is your phi. From this I can determine R and XL. From the phasor diagram, from this phasor diagram, cos phi is equal to R by Z and sin phi is equal to XL by Z. We know Z and phi. We know Z and phi. We can determine R and XL. What is R value?
2.2.
How much?
2.2, sir.
2.2 ohms. XL value?
8.13.
Okay. In this way, we'll determine R value and XL value. Now in the problem, what else he is asking? What is second bit?
Power factor of the load.
Power factor of the load. Power factor is cos phi. We know phi value. Cos 74.78. This is the value, cos phi. 0.2.
0.26.
How much? 20 or 26?
26.
Okay, 26. 0.26. Power factor. Lagging or leading?
Lagging.
Lagging. Because in inductive circuit, current lags the voltage. Next third bit is reactive power. Reactive power is Q. Q is equal to root 3 VL IL sin phi. Or we can take 3 V phase I phase sin phi. In star connection, IL is equal to I phase. In star connection, IL is equal to I phase. We know all the values. If you substitute, you will get the value. Take any formula. VL is 440. V phase is 254. And IL is equal to I phase. We know IL, that is 30. I phase is also 30. And we know phi.
Two 21945.6.
How much?
21945.6.
See, everyone is getting this answer. I think in your textbook they have given 14083. 14083. Unit is VAR. See whether this answer you are getting or not. Volt amp reactive.
Sir, sin pi value also we have to take, no, sir?
Sin phi, sin phi only. Sin of, okay. Sorry, how much you are getting?
0.96.
0.96.
No, sir, sin pi value.
Okay, sin phi is 0.96. Okay. Now tell me the answer.
2194.56.
2194.
5.6.
5.6.
Yes.
VAR, volt amp reactive. Because in your textbook they are getting phi value different. That's why they are getting different answer. Sometimes in textbook they will give the wrong calculations. Okay, this is the value. Unit is VAR, volt amp reactive. What is the unit of P?
Watts.
Watts. Unit of S?
Volt ampere.
VA. Unit of Q is VAR. Please remember the units. That's all about this problem. So we have completed the star connected problems. So in three phase, we are having two connections. One is star connection, and the one is delta connection. We have completed the star. Now we will go for the delta. Star is series or parallel?
Series.
Series. Delta is parallel connection. Okay. Delta is parallel connection. In parallel connection, voltage will be same or different?
Same, sir, same.
Voltage will be same. Current is different. Current is different. In star, current is same. In delta, voltage is same. Okay. In star connection, voltage is different. That is, VL is equal to √3 into I phase. But in delta, IL is equal to √3 into I phase. IL is equal to √3 into I phase. See the difference? Here in star, VL is equal to √3 into V phase. But in delta, IL is equal to √3 into I phase. Take down this.
Done, sir.
Okay. There is a delta I am drawing. This is your delta connection. There is no need of neutral in delta connection. 1, 2, 3 phases. This is your delta connection. Delta is the parallel connection. One minute. Listen here. Let us take the coils. This is the first coil. This is second coil. This is the, I'm having 3 coils. I'm discussing about star connection. See here, star connection. This is the starting point of the coil. This is finishing point of the coil. This is starting point, finishing point of the coil. This is starting and finishing. Starting and finishing of the coils. 3 coils I am taking. This is the first coil. First coil. This is the second coil. This will be the third coil. I am taking 3 coils. Starting and finishing of the coils. Now see here, all these starting points, these 3 starting points are connected to one common point. All the starting points, starting, all the starting points are connected to single point. All these starting points. And the finishing points I am connecting it to 1, 2, 3. Finishing, this is the starting point of the first coil, finishing. Finishing I am connecting it to phase 1. This is starting is connected here, second coil. Then finishing is connected to, the finishing is connected to phase 2. Starting is connected here, this starting of this coil. Finishing is connected here, third coil. This is the star connection. In this way we are getting the star connection. In this way we are getting star connection. Now this common point can be taken as the neutral. This common point can be taken as the neutral terminal. All the starting points. This point is taken as the neutral terminal. Like this we are getting the star connection. Like this, we are getting star connection. Now I will go for the delta. See how we will draw the delta.
Sir, here
Tell me.
first one finishing point is connected to the both the
Finishing point is connected only to phase 1. This is a starting point, finishing point, phase 1. See here, this is the first coil. This is starting point, this is finishing point. Finishing is connected to 1. Now take the second one. Where is the second one? This is second one. Starting. This is starting. This will be finishing. Finishing is connected to 2. Now take the third coil. Starting is connected here. Finishing is connected to phase 3. Finishing is it okay now?
Yes, sir. Before you wrote that S at the top and S no.
I might have written wrong. You take this.
Sir.
This
Okay.
starting. All the startings are connected to neutral. Okay. All the common points, this common point, all the 3 coils starting common point is connected to the neutral. This is the star connection. Now we will go for the delta connection. Now we will draw the delta connection. See here, finishing is now the finishing is connected to starting here. Finishing end of first coil is connected to the starting end of the second coil. In delta, finishing end of first coil is connected to starting end of the second coil. Similarly, the finishing end of the second coil is connected to starting end of the third coil. Finishing end of the second coil is connected to the starting end of the third coil. Now see this one. The finishing end of the third coil is connected to the starting of the first coil. Finishing end of the third coil is connected to the starting end of the first coil. Now listen here, I am taking the first coil here, see. I am taking the first coil in delta. Let us take this is starting. This is starting and finishing. First coil you take. One second. This is starting and finishing end of the first coil. The finishing is connected to the starting of the second coil. Finishing, starting. Finishing and starting. Let us take this is phase 1. Phase 1 starting, finishing. Finishing end of the first coil is connected to starting end of the second coil. Finishing end of the first coil is connected to starting. Now for the second coil finishing end should be connected to starting of the third coil. This is the starting of third coil. Now this is the finishing end of the third coil. This is finishing end of third coil is connected to starting of the first coil. Finishing end of third coil is connected to starting end of the first coil. Is it clear? Let us take, this is the coil 1. Coil 1 starting, finishing. Finishing end of this first coil is connected to starting end of the second coil. Finishing end of second coil is connected to starting of third coil. Finishing end of the third coil is connected to starting of the first coil. This is the delta connection. This is phase 1, phase 2, phase 3. And this delta is the parallel connection. Because we are getting one node point here, I am getting node point here, I am getting node point here. 3 nodes I am getting. 1, 2, 3. In the node, current will divide. That's why it is parallel circuit. At each and every node, current will divide. That's why it is called the parallel connection. We are getting 3 nodes. If you are getting the node point, means that is the parallel connection. That's why delta is the parallel connection. Any doubt in the drawing the circuit? Delta connection. Okay. I am removing this. Now we'll go to the problems. Before going to the problems, we'll draw the phasor diagram. In star connection, we have taken V1, V2, V3. But in delta connection, we will take I1. Because in delta, current will be different. In delta, current will be different. In star, current is same. That's why we have taken for voltages. But in delta, voltage is same. In delta, voltage is same. Current is different. Current is different. That's why I'm taking current. In star connection, we have taken the phasor diagram for voltages. But in delta connection, we'll take the phasor diagram for the currents. 3 positive phase currents, 3 negative phase currents. Minus I1, minus I2, minus I3. 3 positive phase currents, 3 negative phase currents. Now in between I1 and I3, we can draw the line current. To construct the parallelogram, this will be I13. This will be I13. And relation, we can derive the relation. Drop a perpendicular. Drop a perpendicular. I13 is equal to, this value is I1 cos 30. And this value is minus of minus I3 cos 30. Already I have derived this for V13. V13 is equal to V1 cos 30, relation between line and phase current. That is I1 cos 30 plus, here I1 is equal to, I2 is equal to, I3 is equal to I phase. I am taking the magnitude of phase currents equal. In place of I3, take I1. That is I1 cos 30. That is 2 into I1 cos 30. That is 2 into I1 cos 30 is root 3 by 2. 2 and 2 is going to be cancelled. That is root 3 into I phase. IL is equal to root 3 into I phase in delta connection. In delta connection, IL is equal to root 3 into I phase. This is similar to voltages in star connection. In star connection, V13 is equal to, we have taken V1 cos 30 minus V3 cos 30. Here we got V phase, V1. V1 means V phase. I1 is equal to I phase. Write on this. If you are hanged out, you can ask me. In the last class, I had derived for V, for line voltage and phase voltage in star connection. But in delta connection, IL is equal to root 3 into I phase. And VL is equal to V phase in delta connection. In delta connection, in parallel circuit, voltage will be same. In parallel circuit, voltage is same. VL is equal to V phase. The relation between IL and I phase. Only in exam they'll ask VL is equal to root. The star connection only they'll ask. Until now, they have not asked the relation between IL and I phase in delta. Only in star connection, they'll ask to derive the relation between line voltage and phase voltage. In star connection, VL is equal to root 3 into V phase. In delta connection, it is IL is equal to root 3 into I phase. Until now, in exam university, they have asked that to derive the relation between VL and V phase only, in star connection only. But you should know how to derive in delta also. IL is equal to root 3. In star connection, IL is equal to I phase. In delta connection, VL is equal to V phase. In delta is the parallel, that's why voltage is same. Star is series, that's why current is same. Okay, I'm stopping here. In the next class, we will do the problems on delta and we will complete our second unit in the next class. By tomorrow, we will be completing the second unit. So for the mid-exam, I will be giving first 2 units. In mid-exam, only first 2 units are there. And I will be sharing some questions today to you. Some 25 questions I will give. From those 25 questions, you'll get the problems in exam, questions in exam.
Okay, sir.
Tell me.
Nothing, sir.
Now I'll take the attendance, wait for some time.
Okay, sir.
Seven is absent. 11, 12 is also absent. Eleven is present, I think. So these are the absentees. Now we can exit the class.